Thanks, Thorsten. Hello, everyone. My name is Erik, and in this talk, I'm going to tell you about a new phenomenon that is called the citizen developer. I will tell you how the citizen developer creates apps by use of so-called online app generators, and I will tell you how these generated apps affect security and privacy in the mobile ecosystem. But first things first, what is a citizen developer? So citizen developers are persons or developers with little or no software engineering background. Now you could ask, why should such a person develop software in the first place? Well, this term was coined during the evolution of the web development, where basically in the early days only experts could write websites. Now today, with the increasing demand for websites, literally everybody can create a fancy website. And they can do this by use of so-called web builders, like WordPress or Weebly. These web builders abstract from technical aspects and require you only to provide content. You have to choose a layout or design and press the publish button. That's it. And now we are facing a similar trend in the mobile domain. So there's an increasing need for apps. So for instance, small companies that cannot afford in-house development. You have clubs, sports event organizers, and also individual persons that have no IT background at all. So in contrast to the web, those mobile app builders have to account for different mobile ecosystems like Android, iOS, Windows Mobile. And the equivalent to those web builders for citizen developers are online app generators. So they provide a wizard-like point-and-click web interface, which you can use to compose apps by use of so-called predefined software modules. And the key aspect here is that you must not write a single line of code. To show you how this looks like, this is the web interface for the app generator app machine. So you have a preview of the app on the right side. You have your design space in the middle. On the left, you have the selected modules that are shown here as Lego blocks. So you can add new blocks that come with a predefined functionality. So you can integrate video, you can integrate social media, RSS feeds, web views, and so on. And these app generators literally allow you to create apps within minutes. So the first question that came into our mind was, okay, is this really a new phenomenon in the mobile domain? Or is it already an established phenomenon? So is there already kind of a market penetration? So we wanted to find that out. And to that end, we built a classifier that takes an Android app, extracts some high-level characteristics like package name, code namespace, included files, and also extracts information from the signing certificate. And using this classifier, we basically could map apps back to their generating service. So we applied our classifier to a Google Play app repository that had about 2.3 million apps. And what we found was that already 250,000 apps are generated by these online app gens. In other words, more than 11% of the entire App Store, of the Google Play App Store, is generated by developers that have never written a single line of code. So there are a few more popular app generators. So the top 5 that we found account for about 3/4 of all generated apps. And what you could think, okay, if you use these online app gens, basically the outcome will be a very simplistic app. Then you are absolutely right. You cannot recreate a Facebook app with such a service. But you can create very popular apps. So we found different apps of different app gens that already had more than 1 million downloads. So for instance, some virtual DJ app, some nightlife app. So we could already see that there's a really large market penetration. But what we don't know is how do these app gens generate their code. So if you don't have to generate the code, they have to. So we wanted to find out what is the app generation model. And if we find that out, are there specific security issues related to this generation model? So to that end, we first gathered the data set. So we subscribed to the top 13 online app generators according to our market analysis. 7 of them were free, 6 for which we had to pay monthly subscription fees. And we generated the exact same 3 apps for each app gen to get kind of a ground truth. So the first one was a classical Hello World app, so the smallest app that we could possibly generate. The second app basically was app 1 with an additional web request to our server. And app 3 was basically, again, app 1 with a module for user login or form to submit user data, so a sensitive operation. We additionally then took 10 random apps per app gen, and then we could basically start off our analysis. What I haven't told you so far is that we stumbled across that topic a bit differently than what I've told you at the very beginning. So we regularly conduct different security analysis on our app repository, and what we found was that there are large clusters of apps that show the exact same results, typically assigned for spam apps. But as we got to know, these were generated by the online services. So the first idea was, okay, there's probably some kind of code reuse involved, so let's measure the similarity of bytecode of different apps generated by the same service. And to that end, we adopted a technique that we use to detect third-party libraries in apps. That is, we generated hash trees, so-called Merkle trees, over the class hierarchy that we could extract from the bytecode. And then the result is basically a Merkle tree, which you can see on the right. It's a hierarchical tree, basically with 3 layers, a package, class, and a method layer. And that is because Android apps are written in Java or in Kotlin, and this code is organized in hierarchical namespaces. And these namespaces are preserved in the binaries. So we can exploit that fact, parse, and extract those namespaces, and then create such a Merkle tree. If we then compare the code hash, the root hash of different files, we can check whether the bytecode is exactly the same. And if it differs, we can compute a package-based similarity to measure the extent of the code reuse. The surprising result is that there are only 2 online app generators that use module-dependent code, boilerplate code. That means they reuse the exact same code for the same module, but they only generate code for the modules that have been selected by the citizen developer. And this is in contrast to all the other 11 online app gens that use monolithic boilerplate code. This is, say your app gen provides 100 modules, and then they will basically generate the code for all 100 modules, no matter which modules have been selected by the app developer. And these apps only differ in one config file, in one almighty config file. So that caught our interest. So we digged a bit deeper to check how this config file is included. So this config file is typically an XML or JSON file, and there are 2 ways to include them. One is a static config, which basically means you include it in the application binary. And for the dynamic config, it is dynamically retrieved from the remote server. Now, as you can imagine, if you include it statically in plain without encryption, integrity checks, that's not a good idea. But even worse, if you dynamically retrieve it from a remote server in HTTP and without encryption whatsoever, this really opens the door for some severe attacks. And I will show you one of them that we called an app reconfiguration attack. So say you have an app X installed that was generated by some service. Now, upon launch, it will basically retrieve the config from the remote server via HTTP. Then it will initialize the modules, and then it's ready to go. But so far, you can basically predict what can possibly go wrong here. So first of all, if you're on the network, you can read the config file, the data, the content of the config file. And it does not only include the module configuration, it does include all kinds of sensitive data like API, crypto keys, credentials, even information, personal information about the citizen developer that created the app. But even worse, you can also tamper with the config file. You can change any kind of data, so strings, API keys. You can change the API key for advertisement libraries to conduct ad revenue theft. You can also change resources, and you can change URLs. So imagine you create an event app, say for some security conference, and you include a web view pointing to IEEE-security.org. Now you can on the fly change it to something like IEEE-security.org. So easy phishing, there you go, without having to touch the app at all. But as the name suggests, you can even tamper with the code logic. So you can reconfigure the app on the fly. You can change the set of enabled modules, their connection, pretty much everything without having to modify the application code. And the root cause why this works is this monolithic boilerplate code generation with a config that is retrieved from some remote server in plain. So we also wanted to find out what is the code quality in general regarding security and privacy. To that end, we implemented common attack vectors from the literature. And what we found was a long list of security issues. I wouldn't say that these results are worse than for apps from an average developer, but what makes it problematic is the amplification effect. So all those identified issues will be in every generated app of the same app chain. Now, if you have a look at the two module-dependent code generators, we see that they perform much better. So they have less problems with known attack vectors. And that is because they follow the principle of least privilege. They only generate code for those modules that have been selected. And we assume that they also are more willing to adhere to security and privacy best practices. Now, I will give you one more case why this monolithic boilerplate code is problematic. And that is, if you generate code for all modules that you can possibly include, then by definition, you have overprivileged apps. So you have to declare all the permissions necessary to run any code that was included in the application. And in our analysis, this ranged between 7 and 21 permissions. Now, if you include additionally advertisement or tracking libraries, this becomes a privacy nightmare. Because past incidents have shown that especially those kinds of libraries stealthily probe for permissions of their host app. And if the permission is available, they access sensitive data and exfiltrate it to some remote services. And we had one particularly worrisome record of one online app generator that included different tracking libraries that combined issued more than 250 web requests within the first 5 minutes of execution. Finally, we also checked for infrastructure attacks because a lot of app gens basically bind their customers to their backend servers. For instance, if you have modules for user logins or forms to submit user data. So we checked the backend servers against available online SSL TLS analyzers, and we found that only 3 of these services had a valid and trusted server certificate, and all of them ran outdated versions of SSL libraries that were prone to one or more recent attacks like Poodle, Beast, Freak, Logjam, and so on. One of them was even prone to any of these attacks. So by now, you should have the impression that code generation is a bad idea, but this is only partially true. I think the main problem is this monolithic boilerplate code generation. And if you manage to get rid of it and move to module-dependent code generation, this will improve security and privacy of the ecosystem significantly. And one way to do so is app modularization. And there are basically 2 concepts available that allow you to do this. The first one is Android app bundle. So the idea is to split functionality of your app in core functionality and optional functionality that can be installed on demand. The second one is instant apps. So it basically allows users to preview your app or parts of your app without having to install it. And the nice thing is that there's no strong IDE support development SDKs available to support developers in achieving this task. So takeaways from this talk, we have seen different pitfalls of this one-size-fits-all app generation that typically is this monolithic boilerplate code generation. I think app modularization is key to remove large clusters of attack vectors. So for instance, when we move to module-dependent code generation, we can follow the principle of least privilege, which significantly reduces the attack surface. And now with strong tool and IDE support, there are really no more excuses why such an app gen can't do this. And let me conclude with the question whether app generators are here to stay. I would say definitely yes, because there will be an increasing demand for apps, especially from non-IT people. But recently, Apple had removed these templated apps from the iOS App Store. They intentionally marked them as spam apps. And while I could partially follow their argumentation, saying, OK, these apps are an amplification of security and privacy issue, I would still say that this is not the right approach. I think we should turn that argument around and say, okay, if we manage to help those few companies to make their products more secure, then this will be a positive amplification factor for security and privacy. And still, there are tools for non-IT people, for citizen developers, to create apps. And with that, thank you for your attention.
So yeah, please state your name and affiliation too.
My name is Max. I'm with the University of Arizona. I'm wondering if you saw examples where app developers, whether intentionally or otherwise, were pushing out updates via these config files, which to me kind of sound like firmware, and if so, whether or not that would be a violation of the terms of service for developers on the Play Store and the iOS App Store, since you are supposed to push updates programmatically through those stores.
Yeah, but they don't change the code. I mean, they only change which code is enabled. So it's only like you update a config file. So actually, the app, the code in the Play Store is always the same, so there won't be an update. And it also differs from app gen to app gen. So some app gens also publish the app for you, while others say, okay, we just generate and you have to push the update. So if you change something with your app, then basically you have also to push the update. And it depends whether you have monolithic boilerplate code, then the app code is always exactly the same, no matter which configurations you chose. If you have this module-dependent configuration, then it really changes. So your published app basically changes, and you have to upload it again. But I would say it's a gray zone, especially for those monolithic boilerplate code generators.
Okay, I mean, that would still be a contradiction, I know, of the iOS App Store terms, because even if you update like just an image asset, you have to do it through an update to the app if it's a static asset.
Yeah. But I guess it was not the main reason why they banned those apps. Maybe a contributing reason, but the main reason was basically, okay, those low-quality apps, security and privacy issues.
Cool. Hi. Erik, Penn State.
Hi.
Do you think that Android's new stance of requesting permissions at the time that they're used instead of installation is somewhat mitigating the effect of the overprivileging of the monolithic app?
I don't think so, because I mean, it's basically that code. So it's just included, but you as an attacker can enable it. But you can also attack certain things. For instance, it can be a content provider that leaks internal data, and it's not protected by a permission. So an attacker can just attack this component without the user noticing it. Oh. Of course, if it's somehow protected with permissions and it has runtime permission, not all of them already adopted runtime permissions, then at least the user is shown some warning or some request.
Great, great work, thanks.
So Robert from Idaho National Laboratory. Did you do any analysis of the percentage of applications that were malicious or were spam or anything like that from the generators?
I don't think that you can generate malware with those services, because basically there's no predefined module called malicious activity. Or do you think something?
Malware in terms of functionality that, like, not spyware, but just something that
tracking,
spam
leaking,
or something that a user might not want. So just using the generators as a vehicle for sending spam or something to that effect.
It depends on the implementation of those modules. So we didn't see any difference between free and paid apps. Typically, you would say, okay, the paid apps are free of advertisement and tracking, but they are not. And I don't think they intentionally generate malware. It's basically they use some libraries to build some functionality, tracking, advertisement, and if these components leak, then basically this will be an amplification factor, and basically each app will leak the data then.
Okay, yeah, thank you, Erik.
Thanks.